This video is going to extend our discussion about correlation and linear regression into finding the line of best fit so we can actually make some predictions about information, which is the whole goal of what modeling is meant to do. So the example that we're going to look at is muscle car horsepower. In the 60s and 70s, muscle car horsepower ratings were normally set lower in advertising than the cars were actually capable of. For insurance purposes, and so you can enter a more favorable class in drag races. So the first thing that we need to do is determine the independent and dependent variable. So I've got two statements here. Actual horsepower determines what the advertised horsepower will be, or advertised horsepower determines what the actual horsepower would be. Out of those two, the first one makes more sense. So our actual horsepower is going to be the independent variable. The advertised horsepower is going to be the dependent variable. Down below, we've got some data about various muscle cars and then the scatter plot here. So the scatter plot just shows our trend. Okay, from our data, we can see that the higher the actual horsepower, the higher the advertised horsepower, which is what we'd expect. So two variables have a correlation if there is an apparent relationship between them. And we use the term regression to describe finding the line, we'll put or curve, that best fits the data. So if the data looks linear, we use linear regression by finding a line of best fit. And the line of best fit should be drawn so that it best represents the trend in the data. We can also do non-linear regression by using a parabola, an exponential, or another function. We're not going to do this by hand, but Google Sheets or Desmos can do it just as easily. So here we have a line of best fit drawn through our scatter plot, and we're going to do one example of actually finding the line of best fit by hand. We could do it using these fancy equations, or we could do it the easy way by drawing a line of best fit on the scatter plot. And then we're going to pick 2 points and find the equation of the line. Let's go ahead and find the equation of the line of best fit for our muscle car scatter plot. So let's choose our 2 endpoints here. I think this would be, let's see, this is about 33, halfway is about 16. So let's say we're at about 256 and 250. And then over here, we've got about 526 and 450 as my other endpoint. So the first thing that we need to do is find our slope, which is going to be y2 minus y1 over x2 minus x1. And then I've got my slope as, let's see, 450 minus 250 divide by 526 minus 256 is about 0.74, pretty close to this value right here. And then I'm going to find my y-intercept. So I've got y equals 0.74x plus b. I'm going to substitute in my second point. 450, 0.74 times 526 plus b. Rearranging everything for b here. Minus 4. Okay, so we've got about 60.76, which is a little bit higher, but that is okay for now. So I've got y equals 0.74x plus 60.76. So that would be the easy way to find the equation of the line of best fit by hand. We are going to focus on generating it using technology. The whole reason for generating a line of best fit is to be able to make predictions about your data. So there are two types of predictions that we can make. Interpolation means finding a data point inside your collected data. And extrapolation means finding a data point outside your collected data. So we're going to do an example of each of those down below. So the first one we're going to look at is the Mustang Boss 429 actually has 420 horsepower. What would it have been advertised at? So 420 horsepower is probably, let's see, 50, 83, where is this be? Got 400. 483. Where are we here? Oh, 420. Whoops. Okay, 420 would probably be in here. So this is going to be interpolation. Okay. And so what I'm going to do is use the graph. So the easiest way is to use a ruler. Estimate this would be about 416. Maybe 420 would be right about here. And then I'll use green, and I'm going to draw a line that goes up to my graph. I'm going to turn my ruler 90 degrees. And then draw a line that goes over all the way here. And that's the point that I'm going to read off my graph. So reading that point, I would have 350. Okay, about 366. This would be about 383, so I would maybe say 380. Fill that in here. We can also use our line of best fit. So we had y equals 0.74x plus 60.76, which we know is a little bit off when we compare it to our graph, which is okay. Our y, this is an x value, so we're going to substitute 420 in for x and see what we get. So 0.74 times 420 plus 60.76 gives us about 371.56 horsepower. So we're fairly close, within about 10, using the graph and using our equation. The second example here, the Corvette 427, was advertised at 430 horsepower, so this is a Y value. What horsepower was it likely to actually have had? So if I go back up here, I'm going to look at 430. So this is, sort of in this range. It is outside. So this is extrapolation. So let's go ahead and use the graph here to figure that out. I'm going to pull up my ruler again. This time we are starting on the y-axis. We're going to go over to the line and then down to the x-axis. So I would have, let's see, about 416. I need about 430. I would say I'm probably right about here. I'm gonna go all the way over, turn my ruler 90 degrees, and I'm gonna go down, and I would say that's right at about 500 there. So then I can also use my line of best fit. So this time, because I'm working from my dependent variable backwards, I'm going to substitute it in for the y. I've got 0.74x plus 60.76. Rearranging that to solve the equation. Gives me about, I'll add some decimal places, 498.97. So pretty close to 500, which was pretty close to the graph. So those are two examples of how we can use our line of best fit.